So here we are back in Visual Studio with our data processor project open. What we're going to do is come to the program file here and we're going to make some changes. Before we do that, we're going to make some changes to the command line arguments. In this version of the app, we're only going to have a single command line argument, and that's going to be the directory that we want to watch with the FileSystemWatcher. So I'm going to remove all of this and instead specify a single argument pointing to the data in directory. Let's just close that. And in the program CS file here, what we're going to do is remove everything after this comment, all the way down to here, and we're also going to remove this process directory method. So the only option that we're going to have at the command line is the directory to watch, so we'll just create this variable for that option. For the sake of this demo, we're still not going to perform extensive command line validation, but what we are going to do is just double check that the specified directory actually exists. We use the static exists method on the directory class to do this. And if the specified directory doesn't exist, we'll just output an error message. We'll wait for the user to press enter, and then we'll just return, which effectively will end the application execution. So now we're sure that the directory exists. Let's just output a comment telling the user that they're watching a specific directory. And now we can go and create the FileSystemWatcher. Because the FileSystemWatcher implements the iDisposable interface, we want to make sure that we call the dispose method when we're done with the FileSystemWatcher instance. So for example, we could use a using block here, and inside this using we'll create an instance of the FileSystemWatcher. And one of the constructor overloads we can use here allows us to specify the path that we want to watch. In this case, it's the directory that the user specified. So now we can make use of the FileSystemWatcher instance inside this using block, and at the end of this using block, the dispose method will be called for us. Because we're working with .NET 6 and C#10 here, we can actually simplify this by making use of a using declaration. All this means is that we can remove these braces and these parentheses and turn this into a using declaration statement. We'll still get the dispose method called automatically for us when this variable goes out of scope. So now we've created the FileSystemWatcher instance, we can go and configure it. Let's start off by setting the include subdirectories property to false, because we only want the FileSystemWatcher to work specifically with the specified directory and not any subdirectories. If we've done some performance testing or we expect a large number of changes in the watched directory, we could go and increase the internal buffer size property. So as an example, let's set this to 32K. If we only wanted to watch for a specific type of file, we can set the filter property. So for example, we could watch for just text files, but in our case we want to watch for all files, so we could specify this filter. This is actually the default, so you don't need to specify ***, but I'll leave it here just for information purposes. Next, we can specify the notification filter or filters that we want to use. To do this, we set the notify filter property to one or more of the notify filters enum values. For the moment, let's set this to last write. We'll see the implications of doing this shortly. So now we've configured the input file watcher, we can go and add event handlers for the events that we're interested in. So for example, if we're interested in responding to created events, we can wire up the created event in this line of code here to the file created event handler method that we haven't actually created yet. If we want to respond to changes, we can wire up the changed event. If we want to respond to deletions, we can wire up the deleted event and also the renamed event. We can also respond to errors in the FileSystemWatcher by wiring up the error event. And finally, we'll just tell the user to press enter to quit the application. Next, we need to go and actually create the event handler methods. To save time, I'm just going to paste these in. So this is the file created event handler. Notice here we've got these file system event args, which give us access to the name of the file and also the change type that caused this event. We've got the file changed event handler, once again making use of the file system event args. So notice we don't have different event args for created and changed events, but you can still get access to the type of event by examining the change type property here. So we'll go and add the file deleted event handler. This follows the same pattern as the other ones. But if we have a look at the file renamed event handler, notice the event args are of type renamed event args. The renamed event args give us some extra information, such as the old file name before it was renamed here. Finally, we'll go and add the event handler for the FileSystemWatcher errors. Notice this time we've got these error event args. And to get access to the exception that caused the error in the FileSystemWatcher, we can call the getException method here on the error event args instance. If we just come back up here, we've created the FileSystemWatcher, configured it with the properties and also wired up the events, but if we run the application now, we won't actually get any FileSystemWatcher events. The reason for that is that when we're ready to actually start receiving events, we need to set the Enable Raising Events property to true. Let's build this to make sure we haven't introduced any errors, and the build succeeds. So let's see next what happens if we run this application and make some changes to the file system.